All right. So in this little tutorial, we will talk a little bit about Google Books and how we can use this information for data analytic purposes. And at the end, we'll also talk a little bit about Google Trends. So many of you are probably familiar with Google Books. If you go online, you can certainly look up any Google Books and you can search them. And so at some point, some clever people came up with an idea to quantify uh, what Google Books are and quantify the numbers of words in these different books over time. For copyright reasons, we cannot read all Google Books, but we can count them because that scrapes the information about the license property. And so instead of that, we can, instead of this Google Books here, we can go and look at the quantified informations that you can find in Google Books. And so initially this project that started the so-called culturenomics movement, computational linguistics movement, came up with this idea of having an easy web interface called Google Ngram Viewer. And using this Google Ngram Viewer, you can look up various relationships. So here, for instance, what you see using this very simple interface is the frequency of the names Albert Einstein, Sherlock Holmes, and Frankenstein. And so you can see over time in English, there's this tendency of the mentioning of the names to increase. And at some point, Frankenstein became more popular for whatever reason. And now, what is interesting is that you can do much more than this, and we'll get to that in a second. But just counting, if you're really interested in this data, just counting the numbers by following the line and copying what is in it may not be the most efficient use of your time. So instead of that, what we could do, we could use the same information that is already presented on this website and try to scrape it from the Java application and convert it into a table. So that's what we will do. So to do that, we first need to get certain libraries. So everything that we'll do today, we'll do in R. And what that means is that you have to be a little bit familiar with this programming language. And the library that we need, so in R, you have different libraries or packages that you need for different types of analysis. And the library that we need first for Google Ngrams is the one that was developed by Sean Carmody, and you can find it on his GitHub website. It's not available in the repository, used to be, but I think Sean stopped working on it. But it's still available on his GitHub website. So this is GitHub website. The link for that you can follow if you stop the video. And specifically, it describes how you can use this package and what you can do with that. So we'll go through that in a bit, but first we need to obviously get the information, get this package. And so what we need for that is we need to download it. So there are different ways to download it. One way is straight from GitHub, and sometimes that presents some challenges. So in order to get it from GitHub, you first need to install developmental tools package. And then you would need to copy this line, install GitHub into R, into your R interface. And after that, it will install it. So as it says, it may not always work. So instead of that, what we could do also, the bulletproof method, so to say, is to download the zip file. So here's the zip file. We can save the link for the zip file somewhere. And after we saved it, we can open it using the command install_local. So this is what I've done. So I still installed these developmental tools, but we don't need them right now. Instead of that, we need to install that zip file that I have already downloaded. So let's do that. Here I say install local, and then I just say choose dot files, and then open and close parentheses, and then it forces to pop up a window through which I can navigate to a particular location where this zip file is located. So let's do that. So we'll just mark this to pieces and we'll try to run it. By the way, when you do that the first time, one of the first things that often happens is that your interface, if something else is loaded, may interfere with installing these packages. So I always recommend to go in your RStudio into the session and restart R. So just to be sure that nothing else is loaded and nothing else prevents you from installing this package. So okay, so let's go, mark this, click on run. And so now the new window will pop up. Here it goes, this new window. And I save this zip file here, ngrams master.zip. That's the file that I have. I click on open, and it will start now installing it. Will take a few seconds. It asks me if I want to install one of those packages. Would you like an update? In my case, it's because I already installed the rest. In your case, you'll probably need to install all of them. I'll just say, sure, why not? And I'm installing a package. In your case, it will take probably a little bit longer. And it compiles all those packages together. And ultimately, eventually, it says done. Ngram R is installed. So now after the Ngram R is installed, we have to load it. And that's what this library Ngram R is for. In addition to that, I will load several other packages to format your data subsequently. One of them is just for formatting the data tables. The other one is to read Excel files because we'll read in some additional information. And another one, deeply R, to format the data. ggplot2, which is a package to visually represent your data. And in addition to ggplot2 called ggthemes, which will give us some additional visually appealing templates. So, okay, so let's load those two. We have them loaded. And now we can go into analysis. So let's go back to this Google Ngram viewer. So here we can enter any term. Let's say we enter Justin Trudeau because we're in Canada here. Well, let's just put Justin for now. Just the name Justin in English. I mean, that may be interesting. And we will look at English in total. Here you can see that you can, of course, have many other libraries. Let's start with 1900s until 2009. And we will look at the popularity of the term, of the word Justin. And we can even look at it capitalized and non-capitalized. There are two Justins. The Justin just in all in capitals. Apparently there were some around 1880. And Justin, that's just the first letter is capitalized. And the popularity has been going down. It was much more popular in the 1860s. Of course, there were many fewer books back then. And it seems like the popularity is picking up. So one thing you'll notice here is that for whatever reason, the Ngram viewer doesn't really have the proper years after 1880. That happens sometimes. That's another reason why instead of using this interface, we may want to switch to another interface. So how do we do it in Ngram viewer, in Ngram R? So here we need to write a code. And specifically, the code that we're looking for starts with Ngram, And then first in parentheses, we will put a string of the search terms. And because I have more than one, I put them, I say there are several columns, see, and the actual search terms go into in here. As you can see, I look for Yeti, Bigfoot, and Sasquatch, and I will just compare those three. Now, here's some additional features that you can look at. The first one is, when do you want to start? Well, let's say we start in 1750, and then you can also look when you want to finish, but let's say we look at all of this until 2008, which is when the corpus ends. Google Books and for Ngrams doesn't continue beyond 2008. And specifically, we look at the corpus of English fiction from 2012. There are multiple type of corpora that we would be interested in. The difference between the fiction corpus and the general corpus is that the fiction corpus specifically focuses on books. It's a smaller subcorpus, whereas the big corpus has many more scientific books and other type of books that may skew your results, and we'll get to that in a bit. What else? So after the comma here, and this is, by the way, you can put them in different order. It doesn't have to be in this order. We indicate that we actually don't care if it's a capital a Yeti, capital Bigfoot, or if it's lowercase. So case insensitive is equal to true. Then we want to have the counts of those, not just percentages. That's another important thing. So we actually have the raw information here. And finally, we will look at the smoothing component. Now, what is smoothing? When you're dealing with time series data, you'll have a lot of noise from year to year. And so sometimes what you do, you would smooth over the nearby points. And that's what we do here as well. But for now, if you really want to have the raw data, you may not want that smoothing at all as a first step. So even though the default is smoothing of 3, so 3 consecutive years are smoothed over together, here we just get rid of any smoothing. There's no smoothing whatsoever. Smoothing equals 0. Okay, so this is our equation. This is what we want to get. Yeti, written in any possible way. Bigfoot, written in any possible way in Sasquatch, from 1750 in English fiction. And we can then do two things. We'll save it right away here. In R, this would now become a new object that saves this information. And we can then subsequently inspect it. So this is what we'll do. We'll run this. This will right away send the request to Ngram viewer and get the information from the website. So I'm running it right now as we speak, and it's been saved. How do we know that? Because if you look into the environment space of the RStudio, there we see there is a data. Let me click on it. What you will see now is that we have years from 1750, as we specified, until all the way 2008. And what else do you see? Well, we used only one corpus. It tells us that the corpus was English fiction from 2012, which is the better corpus. There's another one from 2008, but we don't care about that one. Then the phrase, there are 3 different phrases, but look at this, they're spelled differently. And we'll get to that when we visualize that. It will be easy to see. And the frequencies, fairly low frequencies, of course, relatively to the books. And we can look both at frequencies and the raw counts. How many times were these terms mentioned in books? All right, so let's go back to our window. How do you want to plot this? Well, to plot this, we will use the ggplot2 package, which I already loaded. And in ggplot2, we basically just say ggplot, plot this, use the Yeti data set. We created this data set now. and specify that the x-axis is year, the y-axis is frequency. And if you look back at how a data set is structured, so year is here, and the frequency, those are percentages. Those are actually, that's misleading. It's not the frequency, it's the percentages relatively to all the books in that year. So it takes the base rate of books into account, which is very important, because otherwise there may be different number of books published by year if you just look at counts. And color, we will delineate the type of words that we use with different colors. So this is the basic equation here. Then we want to get lines, so it will plot lines over years based on the percentages, different colors representing different words, including different spelling of those words. And I use a particular visually friendly theme GDocs. Will look a little bit like Google Docs. So let's mark this and run. And we can see it now in the window. This is a little bit small, so I will zoom in so we can all see it now. So what do we see? Well, first of all, we see that there was, of course, an increase and there was a lot of noise. So we got rid of smoothing, and because there is no smoothing, it's really hard to see because from year to year, there's quite a bit of fluctuation. But overall, for some of those words, there are tendencies since 1950s to use more of these words, especially I think it's Bigfoot. Now, what else do we see? Because we asked for case-insensitive type of words, we can examine what are all the different types of spellings that are present in the English fiction for Yeti. Well, Yeti all lowercase, Yeti where the first letter is capitalized, Yeti for whatever reason the last letter is capitalized, and Yeti where the first and the last letter is capitalized. Now, you may think that's weird, and I agree with you. Why is the last letter capitalized? Who would do that? No real writer would do that. Well, that's more about the shortcoming and limitation of the Google Books corpus, where they use the optical recognition technology for the text. And it's probably the case that for some of the books, the lowercase I was recognized as higher, sort of as capitalized I. So it's actually it's just a mistake in a scanning procedure. And then we have Yeti where every word is capitalized, every letter is capitalized. Same thing for Bigfoot, 4 different types of Bigfoot and 3 different types of Sasquatch. Well, that's not very informative. We probably want to combine those together. And we probably want to smooth this out a little bit because otherwise it's really hard to see what's going on here. So let's try to smooth that first. So look, I still look at Yeti, Bigfoot, and Sasquatch. I start in year 1750, same corpus, still case insensitive, it's true, and I count the actual row number of words in books. But I will use the smoothing to 3, which is the standard smoothing used in Google Ngram Viewer, which means that every 3 years, it averages the previous years and the subsequent years and with the present year. So it creates sort of an average across those and interpolates this way the years. Okay, so let's save this as Yeti again. This now we change the object Yeti to have a new data set. So I sent a new query to Google Books. I'm doing it right now. Okay, so look, it gave me a warning. It says counts are only hypothetical when data is smoothed. Okay, so the counts are hypothetical because obviously those are averages. Those are not the real counts. Now we'll use this data set now and take a look at the visual representation, same type of information. And if you look at it now, you see that it's now much nicer graph. There is not as much variability. There's still kind of back and forth, but much cleaner, right? So we see that there is this real spike in interest in Bigfoot for whatever reason. definitely much more than in other ones. But until 1960s, you could have called somebody a Sasquatch or Yeti or Bigfoot, and nobody would have cared. But for whatever reason, then Bigfoot really started to become popular. Okay, well, this is still not super informative. You can't even read which of those is what. I find it's really hard, and it doesn't really help what color scheme you use. They're just possibly too many categories. So let's combine the words based on the information that we have. We know that there are different types of spellings for Yeti, Bigfoot, and Sasquatch. And what is really cool about this Google Ngrams is that it allows you not only to look for specific terms, but also for simple arithmetic operations within. So instead of looking just for Yeti here, I tell Google Ngram Viewer to give me a frequency of all this combined. So see, I added the plus sign. I can also subtract, by the way, divide or multiply, and multiply by number if I want. But here I just want to combine all these different ways to spell Yeti, all the different ways to spell Bigfoot and Sasquatch. And the rest is the same, smoothing 3, still case insensitive, but now it doesn't really matter if it's case insensitive or not. Okay, so let's save that as a new object. Send request, saved it, same warning as before because we requested real counts, and because of smoothing, it's only hypothetical. And let's take a look at the results. Now we should have only 3 lines. And indeed, we got 3 lines. And we see that it's Bigfoot that became much more popular. The second one is Yeti. And even though now it seems like Yeti and Sasquatch start to compete again. But this would be a simple demonstration. And as I told you before, to remind you, this is not the frequency, even though it says frequency. We are looking at percentages relative to all other books, all other words in books in the same year. Okay, so this was a fun little example, but really possibly not that informative for us. Let's take one step further. What if you're not just interested in the fiction, but you're interested in other corpora? So Google Ngram Viewer has a wide range of corpora. And you can find what corpora there are by examining here. This is a Google Ngram Viewer page. By going down, and you can look at about Ngram Viewer, and it gives you much more information, including various additional pieces about parts of words, tags, whether you want to specify it, what part of speech you're interested in, and so on. But in the bottom here, you will also see arithmetic operations. But at the bottom here, you will also see that there are different corpora. And you can use the shorthands for it. So we have the corpora for American English, British English, Chinese, then English in general, but it's from any country, and English fiction, that's the one I used. Google Million, which is English with dates ranging from 15 to 2008, but it's sort of a standardized set of books per year. French, German, Hebrew, Spanish, Russian, and Italian. Okay, so but for now, I just looked at English, and we'll get to the pitfalls of these different corpora in a bit. But let's first look at the broader corpus. Remember, this is the pattern that we found when we just looked at English fiction. And the question is, does this replicate in a larger corpus? So what do? We take the same equation. We don't have to change anything except that here we will put English 2012. So it's any book published in English from any country that was scanned by Google and part of the Google Books. Okay, so we'll save that. send the request, save the data available immediately, and plot this. Okay, let's take a look. Wow, what a surprise. It looks very, very similar. The only difference is that the Yeti, for whatever reason, really spiked up after 1950, and it really became a popular topic, but that went down. And then Bigfoot started to take over, and really Bigfoot is the most popular term to describe, well, I don't know what. I guess that still varies by region. Now, note that in ggplot, you can, of course, change the y-axis. Here I didn't change it. I call it frequency, but this is something you can modify. You should modify. If you want the percentages, put the percentage in there. You can also change where this legend appears. Again, all those additional steps I haven't done. But if you look at the ggplot2 documentation, you can easily modify this graph. Okay. This is sort of just the intro. Let me tell you a little bit more about the pitfalls with the corpora. Let's go back to that question because there were a number of scholars from all over the world who became really excited about the Google Ngram viewer and started to extrapolate about various cultural trends and cultural differences, comparing the Chinese to British words to whatever. Now, the problem is that none of these corpora are representative. They are all coming from the US libraries, University of Michigan, National Library of Congress, UCLA, and so on. And obviously, those libraries often have only one book of particular kind. And often, it's not about which books are popular or which topics are more popular. It's about just having a representation of certain books. And that has, of course, a problem. What kind of books do these libraries want? Do the people want more books from China than from Russia? Well, it depends on the political situation. So this type of comparisons of word frequencies across corpora doesn't make much sense. And in fact, all corpora, I would say, besides English, are highly suspect because they are very limited in scope. Now, even the British and American English corpora are probably limited in types of inferences you can make when comparing them to each other. What you could do, you could compare the corpora over time. But you have to be mindful that if you see a cultural trend, that this is mostly a cultural trend of Google Books and not a cultural trend writ large. So this is one thing that has to be pointed out, and there was a lot of criticism about that in the recent past. But as long as you stick to English and you realize that this may not be the most representative corpus of the language that you're interested in, you're probably fine. It's a good first step, though. And so, with this note, let's go back to more interesting questions. So, recently, for instance, I was interested in the question about the role of optimism and how optimism words changed over time. And that by itself may not be a very interesting question, except that you can, for instance, examine if optimism is related to some other indicators. Then it becomes interesting. For instance, if you get the information about optimism and related to information about economic growth, is there a relationship between those two? Well, first we have to get the data. And so let's do that. So first, we need to specify the type of words that we think are related to optimism. And in psychology, of course, we have a certain list of words that have been developed and often used by people in charge of the linguistic inquiry and word count, Jamie Pennebaker and colleagues. And if you have access to that dictionary, there is an optimism category. And from that category, you can extrapolate certain words. So that's what I've done. I got the words such as expect, to hope, confidence, control, to encourage, hoped, hopeful, hopes, hoping, and secure, which, according to this linguistic inquiry and word count dictionary, represent the category of optimism, as well as the different variants of that. So here what I do is I will just look at all those words, starting here at 1750, and I will look at it in the British English, because imagine you're interested in the question of optimism and economic growth during the time of industrial revolution. Then you want to start with Britain, where industrial revolution started. So let's have a look at that. And we don't care about case sensitivity here either. We'll collapse them afterwards in case they're spelled differently. Okay, so we'll just get this, run it. It's still running. It's a bit longer. And now we'll take a look at the results. So this is what we get. Goes in all sorts of directions. I think control is on the rise, but a lot of other categories are going down. I think hope is declining and control is on the rise. So that's the main patterns that you can see here. But this is, of course, without smoothing, so the patterns look a little bit shaky. Anyway, so this is just the first step, but we already have the whole database. Now let's imagine that you just want to get rid of you first want to combine this with another data set, and to make sure that you can recognize that this is the British data set, I will add a little piece to it at the end. To the phrase, I will add .gb, Great Britain, and when we do that, so let's have a look at the data set first. First data set looks like this: year, corpus, phrase, frequency, and count. Doesn't have anything to do with GB, but now we will add this to the phrase. And when we look at it again, as you can see, the phrase now changed. Now, this is specific to Great Britain. This phrase is specific to Great Britain. So we'll do the same in the United States. Let's imagine we want to compare the trends in the US and in Great Britain. Same words, but note that the corpus here is US. Again, zero smoothing for now because we may want to have this raw data. I ran it, requested the information, ran it. And after a few seconds, if the server is fast enough, you get it. Let's plot this. And again, add this piece where we add the .us to this data set. So what do we do first? First, we visualize this data. The pattern looks somewhat similar, where I think control is on the rise and hope is on the decline. But also note there is much more variability here at the beginning. And part of the reason for that is that, again, we don't have smoothing, but also there are many fewer books that were published in the US between 1750 and 1800s. And so that pattern looks like a mess. So we have to be mindful of that. And maybe if you were to analyze this data, the first thing you would do, you would say, well, it doesn't seem to make much sense to look beyond 1800s because I just don't have enough data. There's too much noise in there. What about the data set? Well, here again, we have this data set where we already added .us to it. All right, maybe in the next step, you want to do something else to that. But let's try something else. So this was optimism. We have those words for optimism, and we have them stored in here in our interface. And we'll get to how to download them in a bit. But let's imagine that in addition to optimism, you're also interested in morality. And this is an interesting question. A student of mine and I recently posed, what are the moral words and how are they related? What are the trends for different moral words over time? So here what we can do, as first step, you have to start somewhere. And one way to start is, again, to look at the existing dictionaries of common words associated, let's say, with different moral foundations. The theory about different moral foundations by Graham and Hyde. And Jesse Graham has this Look dictionary, again, linguistic inquiry and word count dictionary just for moral foundation words. And from that dictionary, you can then select certain words that already exist in there. Now you have to be mindful of some things. You may want to ask yourself, am I interested more in the nouns representing people, representing objects, or am I more interested in processes, actions? So we decided to focus more on the processes, and to do that, we would focus on verbs. And because that would be otherwise unwieldy, we'll just take 2 words per dimension of moral foundations, using those with highest frequency. Now, the next step, we were thinking, okay, well, that's good, but then because these are verbs, there may be different inflections. Fortunately, Google Ngrams allows you to have different inflections. Among many rules that are listed on the website, this Google Books Ngram.info /info website, you can see that there are rules about inflections, as well as many others. I really encourage you to pursue this page and look at different variations. And so we could look at the inflections by doing underscore INF in capital letters after the word, and it will give us all inflections for that word. And now, in addition to that, we thought, well, maybe we don't just care about these words in different inflections, but we want this word to qualify a certain noun, certain object, because that would really reflect the action. So we would say we want this particular verb in all possible inflections followed by any noun. So this would just state that there is any noun. And note that there is a space in between these two. It's not just one expression, there is a space in between the two. So what are the words that we selected? Well, we selected protect, defend, damage, attack. So they're positive and negative, representing virtues and vices. Justify, reciprocate, discriminate, exclude, unity or unify, something like that. Devote, betray, united, that would be deceive, obey, submit, and so on. So let's look at that. And we looked at English language just in the US. So this is American English, the 2012 dictionary, without any smoothing. In case insensitive, because we don't care. And let's just run this. Now, this is a large list. And when you run this, first of all, it takes a little bit longer because there's a lot of requests in here. Uh-oh, we got a warning message. It says that, well, maximum number of phrases is 12. And you can't have more than that at once, because otherwise you will really overload our server. So it will just give us the information for the first 12. Okay, so what are those first 12? Let's just plot them. So again, I have this morals data set, I have year, frequency, and phrase. And let's have a look. We run the subset. And we have this whole range of words. It's really interesting is that one of them is really going higher than the rest. And we can possibly look at that later in more detail. What is important for now is that we have a wide range of words for protect, a range of words for defend, damage, attack, and it stops at deceive. It doesn't go beyond deceive. So we know that we probably want to run this again, starting after deceive and continuing. You may also want to consider at this point, do I want all these inflections? Or maybe I want to get rid of some of them. If so, I would then, instead of underscore inf, specify the actual words and combine all the combinations of those words that I want. Maybe some of them just don't make sense. But for now, let's keep all of them. And we'll just continue. If you have an error like this, where you cannot run beyond 12, Well, you just continue with the second batch. So we had to stop at the Steve, which was uh, somewhere here. Exclude, unite, devote, betray, deceive. Okay. And so next is obey. So we'll start with obey until sin. And that's what we did in here. And this would be our second data set, which we'll run and visualize. Voila. So this is our data set. And again, you see quite a number of different words for submit, for clean, for disgust, and for sin. So again, you may want to ask yourself, do I want all of those? Or are there some that I don't want? But for now, let's say we want all of them. Now you have two data sets for morals. And the easy way to combine them is to use the so-called rbind function in R. Now we save this data sets into two objects. One is called morals.us, and another one is morals.us1, the second one, I guess. And now we'll say we want to combine the rows because we just want to patch these rows on top of each other. And if you do that, if you do this a little one-liner, it will combine the rows. So combine, now it's all together on top of each other because the columns have the same names. We didn't have to worry about the columns and anything. It was very easy to do. Now what's next? Well, next we have to save this file so we can export it and potentially use it. The simplest way to do it is to save this file as a CSV format that can be easily read in Excel or SPSS or any other statistical package you may want to use if you don't like using R. What do you do here? Well, the first step is to specify where your saving location is. And you do that by clicking on Session and set your working directory. So I would say choose your directory, and let's say I want to save it on my desktop. That will become my directory. Okay, so now anything that I say write.csv will be saved on my desktop. And now what do I want to save? I want to save this file called morals.all.us because that's the file I just created, right? This one above. I give it the name, morals.csv. And I say that I want to keep the row name. Sometimes you don't, but let's say I want to keep the row names. Okay, and that's it. The file is saved, and if we go to desktop, we can definitely see it right here, morals.csv. And if you open it in Excel, it's this beautiful file that has both the percentages and the row counts for all different words. And starting from 1750 and continuing all the way to the present. Now it's a fairly long file, and maybe that's not what you want. Maybe you don't want the file to be represented this way. Maybe you want it to be represented differently. Maybe you want to have it in the wide format. So let's return to the example of optimism. And using this example of optimism, just to remind you, for optimism, we created a US and Great Britain files that looked very similar to the morals file. Started 1750. All sorts of words. We added the endings .us and .gb with frequency and counts, but fairly long files, obviously, because it goes all the way to the present. Okay, so what we can do is we first may want to drop the name from the data set because we don't really care about it, and but you can keep it, of course. But then you can convert it into a different format. Instead of the format that we have, we will change this with this Dcast function, where we do it year by phrase, and we well, let's see what it looks like, and it converts it into a wide format. This would be, it would take the column year and column phrase. And did we have them before? Well, let's have a look. We have phrase and year. Okay, yes, we did have them before. And then it will create the value based on frequency counts. So let's have a look what it does. If you compare this wide format, now we have different columns for different words. So one row represents 1 year, where different words, information for different words is stored in different columns. Sometimes when you work with SPSS, for instance, or with R, this is the format in which you may want your data to be in. And if that is the case, this is one way to do it. So you would do this Dcast, and you would set year by phrase with using this value variable. So to learn more about this, I encourage you to examine the documentation for the Dcast function. So you would do $Dcast, and then it will give you some more information about it here in a reshape2 package, for instance, or in data table. I think this was from the data table. So you would click on File Dcast for data table, and it will provide you with more information how exactly you would save this file. All right, so let's do the same thing for the American data set. Convert it from long to wide format. We've done that. And the next step would be we want to combine those two. And we now don't want to combine the rows together as we've done before with a morality data set, but columns, because there's a different set of columns. So right now we have this wide data set, wide structured data set, frequency, confidence, and so on for Great Britain. And then we have the US based data set, frequency for control, for confidence, and so on for the US. And if we run the simple function data frame and combine this way, what it will do, it will combine it into one file. So if you don't believe me, here you can click on it. This is a long file. So it takes a little bit to load, and it starts with Great Britain, but then if you continue, it ends with the US. So you see .us at the end. Okay, so it combined the file, and maybe we don't need the second year variable, so we'll drop this from now. This comma minus 22 means that we will drop the variable that is located in the position 22. So that drops that column. Okay, so another thing that you may want to do, you can do all sorts of additional things. I will not go through the details here. This will just make this file look a little bit prettier. But the key thing that you may want to do is you may want to combine this data set with another data set. And let's imagine you have a data set about the wealth in the country. I told you we may be interested in a relationship between optimism and wealth. And we found this data set somewhere in an Excel format. Let's take a look at it. So we looked at the Industrial Revolution, and we got this data set, which has, for different years, the growth, the GDP in different countries. And let's imagine that you don't want all those countries, but let's first load this data set in. It will right away load the second sheet. I specify here read Excel, choose file, so I can pick the location, and I just want the second sheet where we have the full data. So we go to Industrial Revolution, pick the file, and it's loaded. So now we have this file in our as a data frame in R. And now maybe you're interested just in the US subset, and you want to have years, GDP, and the population. So those are the three variables you care about. So those would be the variables that would correspond to the column names in your data set. So if you look at the GDP, you see that country codes, and we care about the US, let's say, and the Great Britain, year, and this is the GDP, and pop is the population. Okay, so this is the data set that you found. Maybe some array coded it for you, got it all together, and then now you just want to have the US. So if so, you would say you use the subset function from this GDP data set, where you would say you only want the rows where country code is equal to the US or Great Britain, and you want to have only the columns that represent year, GDP, and population. Okay, so that I create two variables, one for the US, one for Great Britain. And finally, what I may want to do, I may want to combine the data for the optimism that is already all structured in a wide format with the GDP and population data. And to do that, I will say, hey, R, get this new data set called this way, ng.y.gdp, and add, and what do you want to do here? You want to add this data set, and to this data set, if it is the GDP US, you add the GDP US based on year. And in the first data set, the year is capitalized Y, and the second one is lowercase y. And in addition to that, I want to add the GDP for Great Britain. So here I have the GDP for the US, but now I want to add GDP for Great Britain. Again, if it's matched on by year with the following suffixes, .US and .Great Britain. Again, if you need more information about this, you may want to look at the function left joined. But anyways, if you do this, you will end up with a new data set that combines the information from your Google Books and from the data set that you just created for GDP and population. And here, just to make it pretty, I changed the names of the variables. Subsequently, you can export this. And again, you can write this as a CSV. And remember, the location we have currently loaded is the desktop. So it will save on the desktop this file. This is the name of the file of the object. And the name that we give it in CSV is Optimism, GDP, UK, and the US. And if we do that, it will save the file. We can open it right now. And now you see you have this beautiful data set that has per row a year with frequencies percentage-wise. And at the very end, you also have the information for GDP and population, both in the US and in Great Britain. And for some of that, we don't have the information because it was not available until the 20th century. So see, it starts around here where we get the information both for the US and Great Britain. And that's all you may need for Google Books. But we can, of course, go further. And let's say you're not just interested in Google Books, but you're interested in some other type of big data. And the one that I very briefly want to cover is the Google Trends. Now, some of you may be familiar with Google Trends, but in case you're not, Google Trends, let's take a look at it. You can do them via R, but generally Google Trends can give you the trends. This is the data set that Google makes available for us, and we can look what is currently on in the world, on YouTube, on the web, in the news, in Google News. And you can, for instance, look for, let's say you want to look for Paris, and you can see a frequency, how often this word was used over time. And so this is, of course, very nicely represented on the Google website, but maybe you want to download this information. So here, of course, you can just download it as CSV. But maybe you want to automatize this procedure using R and then combine it with some other data. Well, if that's the case, what you need is the gtrends R package. And so we use this package. It's a very nice package that allows you to do it very easily. Send the request similar to Ngram R and save the data subsequently, reformat it and save the data. So we will use this package. First, you would need to load it, install it if you haven't, and then load it, as well as Reshape2 to use the Dcast or Deeply R if you prefer. That's another way to, another package to reformat your data set. And what I will look for here, very simple. You can set up multiple terms, up to 5 search terms at a time, but I will start with one. And I just take a look at the term Blu-ray. Used to be popular, not so popular anymore. And so we want to look at the word Blu-ray. So the structure is very similar to Ngram R. If you're already familiar with Ngram R, you will see there's a lot of similarity. In parentheses, you have the C because you have multiple, you have the search terms here. And then you indicate what data set you want. You want to use the web-based data set. You can also look at images, news, or YouTube searches. And you can also specify the times. Here I will look at all times that Google Trends has been available for. And so let's run this. So we'll run this first, send the query, and save the data as a new object called google.trends. Okay, we're done with that. So if you look at it, we got 180 rows. Those are different time points. It started in 2004, which is when Google Trends started, I believe, on January 1st, 2004. And then there are a number of hits for the keyword Blu-ray all around the world. Okay. And it goes all the way until now, until the December 1st, 2018. Okay, so next, what you may want to do with this data, I want to reformat it in such a way that I will have, well, let's have a look what happens if I remember what the data set looks like right now. We have dates, we have hits, we have keywords, and then geolocation is the world, so it's kind of the same. And if you use this beautiful function, the data set will change where we just keep the date and then the a Blu-ray around the world. So now it says the world because we added that underscore world. We don't need anything else actually, we just need that information. And well, let's work with that. Let's have a look at it. So we have the Google Trends data set. Our X variable is the date. If you look at it, this is the date. And now Y variable is the Blu-ray world. Now, take a look at this. This is very important. In R, you cannot really have the names be written with the blue ray like this. So you have to R will accept that as a column name, but actually it's just a variable in disguise. So you need to put this little what I don't even know what to call them. Little, it's not really brackets. What are those actually? So, yeah, so it's like quotes, single quotes on top. Only that will recognize it. I mean, if you are not sure, you can always look. Like you could do this. You can say, what are the variables that we have in there? Well, we have this Blu-ray variable, but hey, it's actually not Blu-ray underscore world. It has those brackets. So you would copy and paste it with brackets in here. It's a very important piece of information. Otherwise, uh, R will refuse to run this. We'll say, I can't find the variable. So I would again want the line, and I use the new theme. I use the Wall Street Journal theme. I don't know why, but for the heck of it. So let's take a look. The prevalence of popularity of Blu-ray over time. Well, it's been going up until 2010, and then started to slowly go down. It's like number of search terms, Blu-ray, on the web. That's the history of Blu-ray. Okay, now let's return to our favorite example about the Bigfoot. We can do it, of course, here too. So I'll just demonstrate to you another feature of Google Trends. You can do it not only um, for specific terms, for different terms if you want, but also you can do it by region. And now we're in Canada. We may want to compare it to the US. Where is the Bigfoot more popular? How many hits do we have in the US and Canada? And let's pick the time 2005 to 2012. Exact dates when I moved to the US and I left the US for Canada. So here we go. So this will be on the web. We search for Bigfoot, which was the term that was most frequently way Bigfoot was spelled was the capital B, according to Google Books. So we'll use that term and we'll save this as new object google.trends1. So we did that. So by the way, how did we do it? To get this specifics by region, this geo, instead of as we did before, we didn't even specify that, it took the whole world. We added this new feature, geo equal C, and in parentheses, we specify Canada and the United States, right? And by the way, you can go beyond that. Instead of just looking at countries, you can also look at regions. And now it uses this nomenclature from ISO. And the best way to go about it to find those shortcuts is to enter it and look it up in on Wikipedia. And so then you can scroll down. Those are the different entries for codes for different countries that Google Trends is using. So you would just, if you're interested in Azerbaijan, for instance, you would put that's not Arizona, that's Azerbaijan. Just those of you in Arizona, this is not Arizona. Um, and not only that, you can also go by sub-region. Specifically, you can actually look at different parts of France, different parts of Netherlands, and different parts of the US. So, for instance, if you're interested in Puerto Rico, you could look there, but also within the US, for instance, California can be separated as well. So you just need to look at this website and identify the code of the region that you want. Okay, but for now, I just was interested in Canada and the US. If you want to have more than two, you would just add comma, open open another one, and put the, let's say if I want to have Azerbaijan, I'll put the Azerbaijan in there. Again, just to remind you, this is not Arizona. For the time that we specified here, instead of saying time all, we indicate it again equal, and then start the starting time and end time. And there are different ways to do that. So the best way for you is to look at the GTrends, question mark, GTrends, and it will give you the information about how time is sorted. You can look at the time today. So here in this uh, help window, you can see there are multiple ways to look at it. You can look at all times, or you can structure it by year, month, and day, the beginning, and then space, year, minus month, minus day for the end. And that's what I've done here. So this is year, month, and day. Okay, so let's have a look. If people in Azerbaijan cared about Bigfoot, probably not. All right, so we saved that. Let's take a look at the results. So note I changed this code here now for ggplot because now we have date, we have hits, but we also have different regions. So delineate different regions by color. Okay, and I plot the lines for those different regions. And this is what we see. It's not a surprise. There is not much search for Bigfoot in Azerbaijan. It's too hot there for the Bigfoot. So he decided to escape to Canada. Clearly, the Canadians and the Americans care about Bigfoot, and for whatever reason, there was a spike around 2009 where people really looked for Bigfoot. Maybe there were some signs. But then it all calmed down, and the search hasn't been that dramatic in the last few years. So this would be a way to get at the regional differences in search history in Google Books. You can look both for one term and multiple terms. So here you can do the same thing as Ngrams, looking for Bigfoot and for Yeti. Same time period. Let's save this and take a look at the results. This is the difference that you see now. Yeti, on average, has been searched more than Bigfoot, but as we already noticed, Bigfoot, for whatever reason, became really popular around 2009. There was this anomaly spike, then went back again. And as with the previous data sets, you can save this one. So this data set, GoogleTrends 2, can be saved in the format as before. For instance, if you want to do it in a CSV format, well, if you don't remember how to write this, you can either copy it and change the name here. And let's say this is gtrends bigfoot.csv. And maybe we want to have the row names. Or you can, of course, just start writing. And if you remember the names, it will just start populating itself. But anyway, so if you click on this, mark this, and run this, remember our working directory is desktop, so it will save this file to a desktop again. And we can look at it here, gtrends Bigfoot, and here we go. We have the Bigfoot around the world, and we saved it for Bigfoot and for Yeti. Remember, this is the data set that we have. So those are the key things for how to do analysis with Google Books and Google Trends. As I indicated earlier, you have to be really mindful what these databases represent. They are not representative. They are probably not very useful when you want to do cross-cultural comparisons. However, they can be very useful to just take a look at different ways how people express certain terms, as well as how those trends may change over time. You can mesh those pieces of information with some other pieces of information, such as economic indicators, population growth, to look at other trends over time. It's fairly easy to work with that, but you have to remember the limitations of this platforms, and as well as the fact that if you're really interested in linguistics, you may want to go beyond the Google Books. For instance, one of the most recent frameworks that is more representative uh, would be available on the website of Mark Davis from Brigham Young University. And he actually has the Google Books data set there that is better formatted and better structured. He also has other data sets. So this one, if you sign in, you can right away examine different relationships between different words over time. The only limitation is that in this framework, uh, you will have to either uh, create a new Python or R code to scrape the data from this web interface, or just copy and paste whatever will be populated in here. Now, in addition to the Google Books, though, which is, as I mentioned, is not representative, uh, there are other types of data sets that are available uh, through the same interface. So if you just go back, uh, you can see that Mark Davis has a wide range of different data sets. The ones that I like in particular are the news on the web, the largest collection of constantly growing data, the corpus of news websites. Right now is about 1.3 billion words for each year, and fairly easy to use. But also other type of data sets that allow you to examine, for instance, historical English, Wikipedia, global web-based English, and so on. So there's the Google Books is not the only one that's available. You can also focus on other ways to analyze historical trends over time. And that's all for now. Thank you so much for listening and for watching. And if you have any questions, please feel free to email me